Here's an example in which we're finding the sine of 2a and the cosine of 2a if the sine of a is 12/37 and a is in quadrant 2. So how do we do this? So step number 1. Draw your triangle in quadrant 2 from the origin to the x-axis. It's important you do the x and not the y. Let me show that. So I'll come over here. Oh, whoops. I thought I was using my drawing tool and I was not. There we go. So there's quadrant 2. So I'm going to draw my triangle out. I'm not going to go to the y-axis like that. That's wrong. Instead, we want to go from the origin to the x-axis like that. This is the x-axis, right? And this is the y-axis. Why? Why does it matter? Well, because 0 degrees starts over here on the x-axis. That's just how they made the quadrant, the coordinate system, right? When they made the coordinate system, they made 0 here, and then all the angles are from 0 degrees. They could have made 0 straight up. That was just pure, common practice. So if they made 0 straight up, then we would always want to make our triangles go to the y-axis because all the angles would be from the y-axis. But instead they made 0 on the x-axis, so all of our angles have to be measured from the x-axis. So you've got to make your triangle go to the x-axis. So, and then when you put the angle A, they're saying, we put it right there at the origin, like that. Does that make sense? That way, because really, technically, A is actually right here, to be super precise. A is from 0 degrees. But when we call this A, it's technically, I'll put an R here, it's the reference angle for A. It's the same effect as angle A from the nearest x-axis. It's technically the reference angle for A. And the point is, it'll have all the same trig functions. Sine, cosine, tangent will all be the same as if you did the original angle A, which is really from 0 degrees, because you went to the x-axis in the triangle. So that's why we do that. You probably don't care about too many of those details. Let's just get on with the problem. So step number 1, draw the triangle in the second quadrant from the origin to the x-axis. Step 2, use SOHCAHTOA to find two sides. So what are we talking about? Well, they told me sine of A is 12/37. Remember, sine is opposite over hypotenuse, so that means this is opposite. This is hypotenuse, right? So the opposite is the one here, crossed from the angle, and this is the adjacent side, and this is the hypotenuse. So the opposite, 12, over the hypotenuse, 37. So I can use that now to find the adjacent side. So you know what to do, right? Step 3, find the third side by the Pythag, right? A squared plus B squared is C squared. So A squared plus B squared is C squared. Which one is the C? The C has got to be the hypotenuse, doesn't it? So there's the 37 squared. A squared, one of these sides is 12. It doesn't matter which one you call A and B. I just made the 12A. Could do it the other way, doesn't matter. 37 squared now. I'm going to use my calculator. What is that? You could do this without your calculator, right? Because these will be on the exam without a calculator. So let me show it without a calculator. 49, 3 times 7 is 21, add 4, 25, right? Add a 0. And 3 times 7, 21, 3 times 3 is 9, add 2, 11. 1369. That's not beyond your ability, right? You can multiply two-digit numbers by hand, right? And then subtract 144. So B squared is 1, 2, 2, 5. 1, 2, 2, 5. Oh, now this might be, yeah, I won't give you numbers quite this big on the real test because, yeah, 1225, the square root of 1225 by hand, that's hard. It turns out it's 35. So I won't expect you to know numbers that big by hand. I'll give you smaller numbers on the exam than this because that's pretty hard. I used a calculator for it. Square root of 1225 is 35. So that means this other side here is 35, right? Okay. So now, that's the other side. So now we've got all three sides in the triangle. Step 4. Find sine and cosine by SOHCAHTOA. And tangent if you needed it, but we don't need tangent on this problem. By SOHCAHTOA. So now we say, okay, we've already got sine, right? From the beginning, they gave us sine of A right in the beginning, 12/37. Or we could do it right now. The sine is opposite over hypotenuse, opposite over hypotenuse, sure enough. Cosine, but what's a cosine? Cosine, remember, adjacent over hypotenuse. So adjacent, that's 35. That's why we did all that work to find that. Over hypotenuse, 37, right? That's adjacent over hypotenuse. So we've got the sine of A and the cosine of A. From this triangle here that has A in it, we've got the sine of single A and the cosine of single A. Now we're going to use those to find the sine of double A and the cosine of double A. How? Find sine of double A, cosine of double A, right? We've got sine of single A and cosine of single A. Find the sine of double A and cosine of double A by the double angle formulas. So now we go to our formula sheet. We go, okay, what is it? Well, sine of 2x is there, 2 sine cosine. So let's do that one first off. So sine of 2a is 2 sine regular A cosine regular A. Sine of regular A, it's right here, 12/37. Huh? Cosine regular A, it's right there, 35/37. So how do you multiply those out? Whole number you put over 1, and you just multiply straight, top, top, top. Again, this is too big to do by hand. You should use your calculator. On the exam, I won't make it so big by hand. That's too big. 840 over 37 times 37. I'm getting 1369, like that. There we go. So we got it. So there is, 840 over 1369. And finally, now we got to do the cosine of 2a also. Let's come on down here. Cosine of 2a, again, use the double angle formulas. There it is, cosine of 2x. I'll just use this first one. Cosine of 2x is cosine squared of regular x minus sine squared of regular x. So it's going to be cosine squared of regular A minus sine squared of regular A. Okay, so what's the cosine of regular A? It's right here. That's why we did all that work with the triangle to find it. 35/37 squared minus sine of regular A right there. 12/37 squared. Oh, wait a minute. Hold everything. I am not doing a very good job on this problem. One thing I forgot about the signs. Sorry about that. Coming back here, this should be a negative 35 because from the origin it's back 35 up 12. So that's a plus 12 but a minus 35. Minus 35. Right? So that cosine should be minus 35/37. I messed that up. Right? That making sense? So, right, and you also know the all students. Remember the all students take calculus? Let me try that again. You know the all students. In fact, let me change the colors so that everything's kind of blending together here. It's not very effective anymore. Here we go. All students take calculus, third and fourth quadrant. So we're in the second quadrant, which means sine is positive, and also his upside down cosecant. Those guys are positive. The other four are negative. So it makes sense that cosine is a negative in that second quadrant and sine is positive. Doubly verified. that 35 should be negative, the cosine should be negative. So right here, this is a negative 35, so this comes out negative 840, doesn't it? It comes out negative 840 over 1369. And the cosine of 2a, this again should be a negative 35, but it's not going to really matter here, is it? Because when you square that, negative vanishes, right? Let's see here. So 35 squared, I'm getting 1225 over 37 squared is 1369 minus 12 squared over 1369. Subtract those. Uh, 1081. 1081 over 13. So this one became positive, so it's just like that. There is our answer for the cosine of the double angle. So the cosine of the double angle actually comes out positive, doesn't it? Positive like that, and the sine of the double angle comes out negative because that 35 was negative. So again, when you make these triangles, you've got to get your signs right. This is a negative 35 because from the origin it's back 35 up 12 to this point. So the 12 is positive, the 35 is negative. You got to watch your signs carefully there when you make these triangles, or just remember what quadrant you're in. You're in the second quadrant. All students take calculus, so you know sine and cosecant, his upside down, his reciprocal, are both positive, and the other four trig functions are negative, aren't they? Sine is positive and cosecant, but the other four are negative. So for sure, cosine's got to be negative, sine is positive. That doubly makes sense.